Welcome back, everyone. We are in module 4, part 2. This is the addition rule. We're going to start with some Venn diagrams. I have a little biography here named after John Venn. And it's a very helpful way to represent events graphically, geometrically, as it were. So the rectangle represents the entire sample space. Each circle represents an event. And so let's get into the actual example. A survey at a local school asked students what club or clubs they were affiliated with last year. The Venn diagram below summarizes the results. Now let's break down what this means. Everything within this circle here represents all the students that are in the drama club. Everybody who's in this circle here are all the students that are in the music club. The 7 represents the students that are in the music club but not in the drama club. The 9 represents all the students that are in the drama club, but not in the music club. The 15 represents all the students that are in both the drama and the music club at the same time. So they're in 2 clubs. The 12 represents the students that are not in the drama nor the music club at all. So let's answer our questions here. Part A says, what is the entire sample space? How many students are in the entire sample space? Well, that's going to be 9 plus 15 plus 7 plus 12. That's going to be the entire sample space. Notice I don't want to double count the 15. So 9 plus 15 plus 7 plus 12. Sample space of 43. Part B says, what are the number of students in the drama club? Well, the number of students in the drama club is the 9 plus the 15. Remember, the 9 only represents students that are only in the drama club and not in the music club. These 15 students are also in the drama club. Part C says, what is the number of students in the music club? That's going to be the 15 plus the 7. Part D says, the number of students in the music, and this is a big one, and the drama. Music and the drama, that's going to be the 15. Part E says number of music or drama. That's going to be the 9 plus the 15 plus the 7. Notice I'm not double counting the 15 twice. And we'll talk about that not double counting here in just a few minutes. But before we do that, let's talk disjoint, which means mutually exclusive events. So 2 events that have nothing to do with each other. 2 events are disjoint or mutually exclusive if they have no outcomes in common. The addition rule for disjoint events, the probability of E or F, is probability of E plus probability of F, because they have nothing to do with each other, meaning they're not going to overlap like they are here. And we're going to use a standard deck of cards. And part A says, what's the probability of drawing a king? And expresses a simplified fraction. Well, there are only 4 kings out of the 52 cards. That means a 1 in 13 chance of drawing a king. Part B says, probability of drawing a 5. Well, when there are 4 5s as a part of this, so probability of drawing a 5, that's going to be 4 out of 52 again, a 1 in 13 chance. Part C says probability of a king or 5. Well, that's because they're disjoint. You don't have kings that are also 5s or vice versa. They are mutually exclusive. So it's going to be the probability of a king plus the probability of a 5. That's going to be 2 out of 13. Chances of getting a king or a 5. Here we have the general rule. So now we're going to assume that we're not necessarily disjoint. And so now we're going to do same idea, but notice here we're subtracting. This is the big deal here. Because if I count everything in E and F and they have overlap, that means I've counted the ones that are in both 2 times, which I need to eliminate. So I'm going to subtract one of those off. So part A says the probability of drawing a red card. Well, half of them are red, so 26 out of 52, or 1/2. Probability of drawing a 5. As we mentioned before, there are 4 out of the 52 that are 5s. That's 1 out of 13. And part C says, what's the probability of red or a 5? Well, now we do have overlap because there are red 5s. So this is going to be the probability of getting a red card plus the probability of getting a 5 minus the probability of getting a red 5. Probability of red and 5 we have here. And I'm going to keep the denominator 52 just to keep it simple. So probability of red is 26 out of 52. Probability of getting a 5 is 4 out of 52. And how many red 5s are there? There's 2 red 5s. There's the diamond and the heart. So 26 plus 4 minus 2 gives me 28 out of 52. And to show you how we can reduce that as a fraction, I can get a decimal and then I hit math and convert it to a fraction. 7 out of 13. So there's a pretty good chance of getting a red or a 5. All right, next up, we have a 12-sided dice. Is rolled, which means our sample space is 1 through 12, which makes sense. And we have event F, which is 2, 4, 6, 8, 10, and event G, which is 8, 9, 10, 11, and 12. And let's start with part A. List the outcomes in events F and G. So and means that they're in both. So what numbers are in both? It looks like just 8 and 10. So this is F and G. It's going to be the subset 8 and 10. Meaning there are 2 elements. Part B. List the outcomes of events F or G. Or G. So event F or event G, that means it could be the combination of the 2. So this is going to be 2, 4, 6, 8, 9, 10, 11, and 12. And there were 2 elements in this one. Here there's 1, 2, 3, 4, 5, 6, 7, 8 of them. Part C, the probability of event F happening. F, there's 1, 2, 3, 4, 5 out of the 12. Part D says the probability of event G. In event G, there's 1, 2, 3, 4, 5 out of 12. Part E says the probability of F or event G? Well, there are 2 out of the 12. And that could reduce to 1/6, but I'll just leave it as is for now. So part F says the probability of event F or event G using our new rule. So that's going to be the probability of event F plus probability of event G minus the probability of event F and G, which we have 2 of those. Part E is not correct. F or G is going to be 1, 2, 3, that's 8 out of the 12. So when we do it this way, we should get the same number. That, of course, reduces to 2/3. So here we go. Event F, 12, event G, 5/12, minus the overlap. That's going to be 2 out of the 12, which gives us 8 out of 12. Same number, as it should be. Not too difficult. All right, example 15. So here we have a table. They want us to give our answers in rounded 3 decimal places. We have it broken down by class, freshman, sophomore, junior, senior, with the totals. And then it's also broken down by whether they're satisfied, neutral, or not satisfied with the student government. So we have our numbers here. Let's start with part A. Part A, what is the probability that he or she is satisfied with student government? So how many are satisfied with the student government? So here we have satisfied. There are 236 out of the total, which is the 371. We want a decimal approximation. 236 divided by 371. 636. So a little over 63% of the students are satisfied with the current student government. Part B. Probability is satisfied with student government. Once again, that is the 236 over 371. Part C. Let's go here. C. Probability being a junior. And we're here. That's going to be 89 out of the 371. Let's get a decimal approximation there. That's almost 24%, 0.240, if we round it off. Let's push that up a little. Part D. Probability that he or she is satisfied and a junior. So satisfied and junior. So how many juniors that are satisfied? That's 65 out of the 371. .175. And part E, find the probability that he or she is satisfied or a junior using the general addition rule. So probability is satisfied or junior. Probability satisfied plus probability junior minus probability of satisfied juniors. Satisfied 236 over 371. probability of junior, 89 over 371 minus 65 over 371. Let's see what we got. 236 plus 89 minus 65. Out of 371. All right, so we got about 70%, 701. F was probably that he or she is a freshman and not satisfied. So probability of freshman and not satisfied. So how many freshmen are not satisfied? That's 15 out of 371. Pretty low, only about 4% are not happy with the student government. Number 16, find the probability that the indicated event, if P of A is 35.35, P of B 0.45, P of A and B is 0.15. So part A is going to be P of A or B is going to be P of A plus P of B minus P of A and B. .65. And I want to point out, if we were to label this in the middle here, we would have 0.15. And here we would have 0.2 because P of A is 0.35. And so when I add those two up, I got to get A. So I actually subtracted 0.15 from that to get the 0.2. I'm going to have to subtract that from here as well to get the 0.3. Right, part B. All right, so here they give us this here, but now they're giving us information. P of A or B, they tell us what that is right here, 0.65. P of A is 0.6. P of B is what we're looking for. P of A and B is 0.1. So now I have an algebraic problem to solve. So I'm going to go ahead and combine up my like terms. Now I'm going to subtract. To get that P of B is 0.15. Good old algebra.